Hello everyone, it's Wilson here. Today I want to talk about how to find the region bounded by the curves, and I am going to use two ways to do it this time. So I'm going to set up the integral and integrate with respect to x, and then I'm also going to set up the integral and integrate with respect to y. Okay, so let's see how we do this problem. And then the first thing that we need to do is to actually graph the curves, right? And then actually this one is a straight line, that one is a straight line, and then that one is a curve. So if we graph all those, and then we can see what the region looks like. Okay, so first, we can graph the square root function right here, but then before we do the graphing, we need to set up the scale so that we know one box is equal to how many units, right? So the way that I'm going to set up is that I'm going to just put, well, this one would be 0, right? Because this is the y-axis. And then I'm just going to say that, let me see. So we are going to use 2 units right here for each box. So we get 2, 4, 6, 8, and then 10. And then you go in the other direction, negative 2, negative 4, negative 6, negative 8, and then negative 10. And then now in the y direction, we can use a different scale for the y direction. And so we can do 0 and then one unit, one box. So we are going to just get all this. Negative 2, negative 3, negative 4, negative 5, right? So now we have everything set up. And then now we can start graphing the square root function. So how do you graph this square root function right here? This is actually quite simple. So for the square root function, okay, which is really just if you plug 0 for the x, you are going to get 0 for the y. So you're going to start at the origin, right? So that's our first point right here. And then if you put in the 1, then you're going to get y equals 1 also. So you are just going to put in the 1, and then y is equal to 1. So that's right here. Because when you see this mark right here, this is 2, right? And then so half of that will be 1. So you get this point right here. And then the next point, it would be a good idea to plug in a perfect square in here, because if you put in the perfect square, the 4, right? The next perfect square will be a 4. So if you put the 4 in here, you get square root of 4, which is 2. So y is equal to 2. So you get this point right here. And then if you want to continue the graph, then the next perfect square will be 9. So you're going to get 3. So the 9 is between the 8 and the 10, right? So we get this point right here. And then we get the curve. Yes. And so that's our square root function. And then now we need to graph the line. Okay, so let's graph the line right here. So let's look at this one. Right, this is the straight line right here. It has a y-intercept. 0, 4, right? So 0, 4, which would be right here. So we get this point. So this is our y-intercept. Now, what happened is that if you just look at the slope right here, this is negative 1 over 2. We can think of it as negative 1 divided by 2. So it's we go down 1 unit, and then we go to the right 2 units, right? So we get this point. And then once we have 2 points, then we can actually draw the line. But if you want more points, you can go down 1 unit and then go to the right 2 units. Remember, the x scale is different from the y scale, right? So we have this point right here. And as you can see, they actually intersect at the point 4, 2, right? And now basically we can already draw the straight line. So if we draw the straight line, then it's going to look like that. And then, but that's not finished yet, because there is no region that's being bounded for now, if we ignore the xy axis, right? But there is another line that we need to bound the region, which is the y equals 0. What is y equals 0? Y equals 0 is actually the x-axis, right? It's the horizontal line when y is equal to 0. So you are going to get this line right here. So y equals 0. Okay, so we got that. Now, which region is bounded? It's this region being bounded right here, as you can see. So this is a region that we have. And then now you may say, how do we find the area of this region? It's actually simple. So now the question is, so which ones do we integrate? And I told you at the beginning of the video that I'm going to do it both ways, but in general, which way is actually easier for this region here? Let's take a look. So if you're integrating with respect to x, you need to use the top curve minus the bottom curve to actually find the height. The problem is that, do you see what's going on here? If you draw a vertical strip, for example, if you draw it right here, as you can see, you see that the top curve is actually the red curve right here. The bottom curve is the green, the green straight line right here. But if you draw it at a different spot, do you see what's going on right here? The top curve is actually the yellow line, and then the bottom curve is actually the green line, right? So see, we do not really have a unique upper bound for this region. And it's actually made up of two different curves. And so in this case, we actually need to set up two different integrals to find the area. So right now, the easier way is actually to integrate with respect to y, because if you draw a horizontal strip, you have a unique upper bound, which is the yellow line on the right, and then the lower bound is actually the red curve. Is that okay? So first, we are going to integrate with respect to y. Okay, so let's do that. So we start by integrating with respect to y. Okay, so that means what? That means we are going to draw a horizontal strip. So how do we do this problem? Because we are going to integrate with respect to y, that means for both equations right here, we need to solve for x. Is that okay? So let's just start solving for x right here. For the red curve, we can solve for x really easily, which is really just done by squaring both sides. So we get x equals y squared. So that's finished. We already isolate the x right here. And then for the yellow curve, right? I mean, for the yellow line right here, we have the y is equal to negative 1 over 2x plus 4. And then if you solve for x right here, you can move the 4 over. So you're going to get negative 1 over x, 1 over 2x, and then equals y minus 4. And then if we multiply both sides of the equation by negative 2, then we are going to get x is equal to negative 2y and then plus 8. And so now we have the x isolated. Now we are actually ready to set up the integral. Okay, so the area, if you want to set up the integral for the area, the integral is actually given by, well, let's just recall here. When we integrate with respect to y, right? So when we integrate with respect to y, okay, to y. Yeah, the integrals should be what? The limits are in terms of y right here. So y is equal to something, y is equal to something. So we have the lower bound for the y and then upper bound for the y. And then what happened is that you're going to use the right curve minus the left curve. Okay, the capital R here stands for the right curve, and then the L here stands for the left curve, right? And then you integrate with respect to y here. And then when you integrate with respect to x, the way that you set up the integral for finding the area of the region, that you are going to use the limits for the x. So what happened is that you are going to have y of the top. So the capital T stands for the top curve minus the y of the bottom curve. The capital B stands for the bottom curve. And then we are integrating with respect to x. So right now, because we are integrating with respect to y, so we are going to follow this idea right here. The limits would be the limits for the y for this region. So what is the smallest value for the y for this region here? It's 0. Okay, so we have 0 right here. Then you may say, what about the upper limit? The upper limit is the largest value for the y in this region, right? The largest value is actually 2, so you just get 2 right here. And so remember, this point right here that we have, this is the intersection point, which is actually 4 and then 2, right? So x value of this point is 4, and then the y value is 2. Okay, so now following this idea right here, we gotta use the right curve minus the left curve. The right curve is actually the yellow straight line, which is this one. So we put down this whole expression right here, which is what? Which is just the negative 2y plus 8. Is that okay? So this one minus now the left curve. The left curve is actually the right curve right here, which is the square root function. But then we solve for x, so we get y squared. And then we have the whole integral setup. This is actually a really simple integral here, so we're just going to integrate quickly. It would be a good idea to just clean up the expression so that there are no more parentheses. So we get negative 2y plus 8 and then minus y squared, right? And then now doing the integration, what happens? We are going to integrate this, which will give us negative y squared. Okay, plus 8y, right, antiderivative, and then minus 1 over 3y to the third power, evaluate from 0 to 2, as you can see here. Okay, so now plug in 2, and then also plug in 0, and then we subtract them. So this is basically using the FTC, right? So we are just going to get negative something squared plus 8 times something minus 1 over 3 blank cube. And then you do the exact same thing right here. So I'm just going to write down the form because it's easier to work with. What happens is that we are going to just simply plug in the limits in there, right? So we plug the 2 in there. So we get the 2, 2, 2. And then for the lower limit right here, we are just going to put in 0, 0, and 0. Yeah, so actually, we don't need to worry about this because everything is 0 right here, right? Yeah, so we don't need to worry about this one. And then all we need right now is to focus on doing this calculation right here. So what do we get here? This is negative 4 plus 16, right? So negative 4 plus 16. And then minus. Okay, so what do we get here? That's 2 cubed, which is 8 over 3. So we get 8 over 3 right here. And then so we are going to get what? 12 minus 8 over 3. And then get the common denominator, we are going to get 36 minus 8 over 3, which is what? Which is just 28 over 3. And then we're finished. So the area for this region that we are getting here is 28 over 3 square units. Is that okay? So that part is finished. Now I want to do it in a different way, which is to integrate respect to x. Okay, so we are going to just do another setup right here. Yeah, so let's look at how this will work. We don't need to do this extra step of solving for x anymore because we already have the y isolated right here. And because when we integrate respect to x, we actually need to write the two functions in terms of x. So what happened is that we got to break the region in two. So what we are doing is that we got to write it so that we gotta break the region like this, and then so that you have two regions right here. So there is one on the left of this blue dash line right here, and then there is one on the right of this blue dash line right here. So the one on the left, let's just make some color on there. So we can do, well, actually I don't want to do the shading right here because it's more difficult, right? To shade. So I'm just going to call this region 1, and then the other region, let's call this region 2, right? And so when we set up the integral, so the area, right? Now we are going to follow this one right here. We use the top curve minus the bottom curve. And as you can see, for both region 1 and region 2, we actually can have a unique upper bound, a lower bound, unique upper bound, and a lower bound, right? So we can set up the integral now. So for the region 1, the integral is actually going from, now we look at the x limits. So we go from 0 to, as you can see, 4, right? Because the x value of the, it's 4 right here. So we get 0 to 4. We get 0 to 4. And then what do we get at the top? The top is the red curve, which is the square root of x. So we simply just use the square root of x right here. So the square root of x. And then we have the dx. Okay, so that's our first integral for region 1. Now the second integral is actually going from 4 to, now let's see what the x-intercept is. The x-intercept is going to be 8. Now, if you're not sure, right, because sometimes we don't have a ruler, then we cannot graph it really accurately, then what can you do to figure out the x-intercept? You can simply set y equal to 0, and then you solve for x right here. And as you can see, when x is equal to 8, so 8 times -1/2, which will give you -4. -4 plus 4 will give you 0. So we know that the upper limit would be 8 right here, as you can see. And so I should really just label this point right here. This point is actually the x-intercept 8, 0. So that's why we have the 8. So from 4 to 8, starting from the blue dash line to this number. And then what is the function that we should be putting here? The top curve is the yellow line. The bottom curve is 0, so we don't need to worry about the bottom curve. Top curve is the yellow line, which is we are just going to copy this right here. So we have -1/2x plus 4, as you can see, and then the dx. That okay? So now we can just integrate, and we are expecting to get the same answer as the previous method, right? Because we're just finding the area, the same region, except that we are doing it in a different approach. So we can integrate this one really easily. And then this one, I will say that we do not even need to do any integration. Why? Because that region 2 is actually a right triangle. So we just need the base and the height, and then we can do it geometrically. Okay, so what happens is that we are going to just do this one quickly. Integrating this would give us what? Well, actually, it's going to be, well, this one is going to be x to the 1/2, right? So we are going to get x to the 3/2. Actually, I need more space. So x 3/2, and then times 2/3 evaluated from 0 to 4. Okay, plus, now, what about the region 2? The region 2, as you can see, the base is what? Is 4 units, because it's from 4 to 8. Now, what about the height? The height is going to be 2 units. So area of a triangle is 1/2 times the base. The base is 4 units. And then the height is 2 units. Is that okay? So let me just do some labeling here so that you know. This one is the base of the right triangle. And then that is the height of the right triangle. Yeah, so now we can just find the area without doing any integration. That would be a lot simpler to deal with, right? Okay, so continue with the calculation right here. What do we get? We plug the 4 in there, and then we get 2/3 blank to the 3/2. Actually, this gets in the way, so let me just erase that. Okay, what number should we plug in there? Well, the 4, right? And then also, when you plug in the 0, I'm not going to write it. You have seen it once already. You plug in the 0, you get 0. So I will just have this term right here. This, we got to do the calculation. The 1/2 and the 2 will get canceled. So we just get the 4. So we have the 4 right here. And then now continue to do this calculation. This is, you take the square root. This is the square root of the 4, and then raise to the 3rd power. So you can take the square root of the 4 first, which will give you a positive 2, and then raise to the 3rd power, you get 8. So you actually will get 2/3 times 8 plus 4, which would give you 16/3 plus 4, as you can see, right? 2 times 8, 16. And then now get the common denominator. We get 16/3 plus, what do we have here? 3 times 4 is 12. And so final answer, 28/3. Same answer, as you can see. Now, even though we broke the region into two when we were integrating respect to x, but as you can see, it's actually not even bad, right? So now it depends on whether this integration is difficult, because when you do the subtraction, even though you set up only one integral, but it may turn out to be difficult. And actually, it can be more work for this approach right here when it's not a shape that we can find the area using a formula. So if you have to do a calculation, then it will be more work. So it's up to you to decide which way that you want to do. Sometimes if you have a region, you may not be able to choose to integrate in either one, because the nature of the problem will just force you to do in one way instead of the other way. All right, but for this problem, I picked this problem because I want to demonstrate both ways so that we can compare. Okay, so this is a fun problem. We'll do more next time. To help make math learning available to everyone, please share my videos to others and subscribe my channel. It will give me support to make more videos. I want to work together with you to help students and children learn math more easily. Thank you for watching. I will see you next.